we got our pre-calc unit 4 review with Lauren, and we're just gonna run through these problems, right? You want me just to run, you have a bunch on here you want me to do so you can review them later? Our pre-calc.
I can add some more. My thing adding pictures was kind of weird earlier, so I'm gonna add some more as we go.
Okay. Do you have a few on here
Yeah.
already? Okay.
Yeah.
This is, I don't know why it's so slow loading sometimes. Try closing and opening again, but hopefully will happen faster. Come on. All right, there we go. Is this it?
Yeah.
Or is this something else?
Wait, let me see.
I feel like I just did this. This was someone else.
Oh
I
no.
was just,
No, that's not.
yeah, this is not you. This
I
is geometry.
10.
Pre-calc?
Yeah.
Yeah, I don't know why that opened up Elliot's. Okay, sounds good. All right, we're solving.
Yep.
Okay, so to solve this problem, we're going to have to take the log base 10 of both sides.
Mm-hmm.
And when I do that, why do I do that? What am I allowed to do with this x when I do that?
You can move it to the front.
That's right. And what's the log base 10 of 10?
1.
1. So this is just x equals log base 10, which I don't have to write the 10, of 120. I don't have to write the 10 because in your calculator, that's exactly what that log is. So I just type in log, which means base 10 of 120, and I hit enter. So approximately 2.08. If they want the answer exactly, you leave this. If they want a decimal approximation, you round it to whatever they want you to round it to after you punch in your calculator. Got it?
Yeah.
For this problem, we are going to combine these together. So combining these together when they're being subtracted, you do x minus 5 on the top and x plus 4 on the bottom. Same with the left side. It's x minus 1 on the top and x plus 2 on the bottom. Now, since I have a natural log on both sides, I can what they call exponentiate both sides, or I can just do what I call the duh property. Like if the natural log of A equals the natural log of B, then duh, A and B have to be equal to each other. That's how I think of it. So x minus 5 over x plus 4 equals x minus 1 over x plus 2. Now cross multiply, we'll do this up here. So we've got x minus 5 times x plus 2 equals x minus 1 times x plus 4. My pencil's not doing a good job right now. So this is x squared minus 5x plus 2x minus 10 equals x squared minus x plus 4x minus 4. Check if I did that right. Plus 4. Yep. So this equals x squared minus 3x minus 10. And on the right side, we have x squared plus 3x minus 4. And now I want to solve this, I need to move everything to the left side of the equation. So that's going to cancel those x squareds out. Subtracting 3x is going to give me negative 6x. Adding 4 is going to be negative 6. And now I can add 6 to both sides. And now I can divide by negative 6, and my answer is negative 1. And then check your answer to make sure there's not an extraneous solution. And sure enough, when I try plugging negative 1 in here, what happens right here?
Become 0.
It becomes a negative 2. Can I take the natural log of negative 2?
No.
or of -6?
No.
No. So I don't circle it and I say no solutions
Mhm.
because this was extraneous.
Yeah.
Make sense?
Yeah.
So there's no solution. After all that work, no solution. Log 3 log x equals log 25. So similar to what we've done before, this 3 can go where?
In the front, like as a power.
It can go up, right, as a power. And if I have log of this equals log of that, what do I know about this and that? They
Like
have to be equal to each other.
yeah.
And what's the cube root of 125?
5.
Done. This, take the log of both sides, because that, after all, that's the reason that you learn logs, so you can get exponents, variables out of the exponent. So when I take the log of both sides, this x comes down. I get x times the log of 4 equals the log of 15, which means x equals the log of 15 over the log of 4. Now, the other way you could do this problem, instead of doing it like that, let me show you a different way, is you could use the equivalence. Do you remember the equivalence? That's the thing that said y equals, sorry, let me try it differently. Log base b of x equals y is the same thing as b to the y equals x. So you can go in either direction with this. So see how this is the exponential form?
Yep.
So to put that in logarithmic form, I could just write, I could go straight and just do the conversion to exponential form. Log base 4 of 15 equals x. And that's the same thing as this. This is just using a change of base so you can punch into your calculator easily. Do you remember the change of base formula for this? Have you learned the change of base?
I'm not. I don't
The
think so.
change of base formula says this. I don't know if they've taught you that yet. I haven't seen it yet with your work.
No, I don't think so.
So the change of base formula says that the log base b of a, let's say, is equal to the log base whatever you want of a over the log of that same base over b.
Okay.
So if you get this problem right here, if you get this answer and you're like, well, how do I do that in my calculator? And you don't know how to find that button that changes the base, then what you can do is you can rewrite it. See how this is rewritten with log base 10? It's the log base 15 over the log base 4.
Oh, we did
And
learn. She like touched on it a little bit.
yeah, that's called the change of base. So that's, I'm showing that to you because this, if you do it this way, you're going to get that answer. But if you do it this way, you're going to get this answer and you might not know how to punch that in your calculator. Now in your calculator, you probably do have, if you know where to look for it, I think it's in math on this calculator, there's the log base. So that's the log base 4 of 15. And it gives you the answer, but you could have just used the change of base and typed in log of 15 divided by log of 4. And you'll get that same answer. Or you could have done natural log of 15 divided by the natural log of 4. It doesn't matter what you change the base to, as long as it's the same base, it's going to still give you that same answer.
Okay.
Hopefully that made sense.
Yeah, that did make sense.
Okay. Next, log. So this one we're going to combine together. So this would be the log of x times x plus 3 equals the log of 10. And again, log of this equals log of that means this equals that. So now I can just say x times x plus 3 equals 10. Now to solve this quadratic equation, right?
Yeah.
So I can't just it's in factored form, but it's not set equal to 0. So I have to expand it actually. and subtract the 10 over. In other words, I need to set it equal to 0, and now I can try to factor it. Hey, look, this factors. It factors into x plus 5 and x minus 2, which means x equals -5 or x equals +2. But now see which ones work when you plug them back in. Can I plug a -5 in for x?
No.
No, it's extraneous. Can I plug 2 in for x?
Yeah.
I sure can. In fact, you can check it. Store 2 for your variable. So 2 store for x. And now type in log of x, and it punches in 2, plus log of x plus 3. And what should my answer be?
2.
Should be log of 10.
1.
What's the log of 10?
1. Sorry.
Yeah, it's 1, right?
Mm-hmm.
So that worked. The half-life of aspirin in your blood is 12 hours. That means I feel like we did this one together on Saturday, didn't we? Want to go over it again?
Yeah, I did want to go over it again.
Confusing? Okay. The half-life of aspirin in your blood is 12 hours. That means in every 12 hours, half of it is going to go away. So I'm going to divide the number of hours, T, by 12, and I'm going to multiply that by 1/2.
Mm-hmm.
How much of the 300 milligrams? So there's 300 milligrams at when time is 0. So the amount that's going to be left in your blood when the time is in 0 hours, what's 1/2 to the 0 power?
0?
No, what's anything to the 0 power?
Oh, 1.
It's 1. So if I plug in 0 for T, all of this is going to just be 1, and your answer is going to be 300.
Mm-hmm.
You get how that works? Let me just show you how this works. When T equals 0, the amount in your blood is going to be 300.
Mm-hmm.
When T equals 12, what's the amount in your blood?
Half of it.
Half of it. What's half of? Do you see how this formula does that for you?
Yeah.
It creates that for you. So if I plug in 12 for T, this is 1, and 1/2 to the 1 power is just 1/2, and 1/2 times 300 is just 150.
Mm-hmm.
That's why it's called a half-life, because after 12 hours,
Mm-hmm.
half of it is gone.
Okay.
How about after another 12 hours, which means 24 hours?
Half of the 150 would be gone.
Half of the 150, which is 75. How about after another 12 hours, which is 36 hours? Half of the 75, which is
37.5.
37.5. Good. How about after another 12 hours? In other words, 48 hours, which by the way is 2 days.
18.75.
That's your answer. Now, you don't need to do this T-chart to find your answer. If you trust this equation, you just plug it in.
Mm-hmm.
But you have to plug in the right thing. You have to plug in 48 here, because 2 days is 48 hours. Or you can use your calculator to do it, right? 300 times 0.5 raised to the 48 divided by 12. 18.75.
Mm-hmm.
Got it?
Yeah.
How long will it take it to decay to 10 milligrams? So now I'm plugging in 10 for A, right? So 10 equals 300 times 1/2 to the T over 12. Solve this equation. Well, we know how to solve equations like this now because we've learned about logs. So first get rid of the 300, right? So it would be 1 over 30 equals 1/2 to the T over 12. How do I get a variable out of an exponent? I take the log of both sides, right? Because that allows me to write it as T over 12 times the log of 1/2 equals the log of 1/30.
Mm-hmm.
And now I can multiply by 12 to get the 12 over and divide by the log of 1/2. So T equals multiplying by 12. So 12 times the log of 1 over 30, all divided by the log of 1/2. And now just punch that in your calculator carefully. Excuse me. Times the log of 1 over 30, and I'm going to divide that by the log of 1/2, or 0.5. 58.88. 58.8827 hours, was it?
Yeah.
Hours. Got it? And they didn't specify what units they wanted for length, so we'll just put it in decimals of hours. If they said how many hours in minutes, you would have to convert this hour into minutes. So there's 60 minutes in an hour. So 0.8827 of an hour would be, you'd have to convert that. I don't feel like explaining that right now because they didn't ask you to do that. Okay. All right, which one do you want here?
4.
How much money will you have after that years if you deposit inheritance at a rate of the compound? Okay, so that formula is this one right here. This is compound interest. So n is your number of compoundings. Number of compoundings per year. That's what n is. T is your number of years. And P is your principal. And A is your amount, your current amount. Okay, so how much money, that means A, they're looking for A, will you have after 10 years, that's your T. If you deposit that much, that's your P, at a rate of that much, that's your R. Compounded oh, I didn't see that part. Compounded continuously means you're using this formula right here. That's your continuous compounding. So you actually, all you need is your P and your R and your T. So P equals, A equals money will you have? That's what they want. If you invest $1,000 times E to the R 0.0345, make sure you put the 0.0 in front of that, times T, which is 10. So great formula, very good to know, because all you have to do now is take, this is your E, it's above the ln of X button, because remember the ln is the base of E, and you're raising it to the point, essentially to the 0.345, because when you multiply by 10, it moves the decimal over 1. So you would have $14.11.99. So almost $14.12. How long would it take for you to triple your investment? Well, to triple it means that my A would be 3,000, because that's 3 times of 1,000, right? And how long would it take? Well, your interest rate is 0.0345, and now you want to find out how many years it would take to do that. So divide both sides by 1,000. 3 equals E to the 0.0345 t. What should they do to both sides to get that variable out of the exponent? Take the natural log, right? Because that brings that down front. So I have the natural log of 3 equals 0.0345 times t times the natural log of E is just 1, right? So that's gone. So t equals the natural log of 3 all over 0.0345. In my calculator, natural log of 3, be careful to close off the parentheses, divided by 0.0345, 31.84. That's how many years you would have you would need to leave it in there until it tripled in value.
Mm-hmm. Okay.
Okay.
Yep.
All right. Do you remember what to do for this one?
Put the x plus 2 over the x minus 1.
Good. So the log base 4 of x plus 2 over x minus 1 equals 1. And now what?
And then,
Wouldn't it be great if we could convert this now to an exponential?
yeah, so for
And we can.
1. Oh, wait, that would be 0, right?
Yep. So we're going to, no, it would be 1. So we're going to write this. This is the same as 4 to the 1 equals x plus 2 over x minus 1.
Okay. Yeah.
Got it?
Mm-hmm.
And so that means now multiply x minus 1 to both sides.
Mm-hmm.
Now distribute the 4 in. Now subtract x from both sides. Add 4 to both sides. Divide both sides by 3. Check your answer. When I plug in 2 here and 2 here, I get 1 minus 0 equals 1 cha-ching. Same deal with this one. Wait, did we do this one already?
Oh, yeah, I think I accidentally put that in there twice.
Yeah, that one looks the same as one we just did. We haven't done this one yet. So log base, same deal, right? Log base 3 of, well, this time we're multiplying x minus 5 times x plus 3 equals 2. So let's rewrite this in exponential form. 3 squared,
Mm-hmm.
right? That's the equivalence that I'm using to do that. Got it?
Yep.
So that's 9. So it's x squared minus 5x plus 3x minus 15 equals 9. It's right in standard form, meaning move everything to the left side, subtract 9. You get minus 24 equals 0. 24 is 6 and 4. So I can do x minus 6 and x plus 4 equals 0, which means x equals 6 or x equals negative 4. And I'm guessing negative 4 is extraneous. It is, because it'll give you a negative when you plug it back in as the argument. So 6 is your only answer. Let's check it. When I plug in 6 here, what's log base 3 of 1?
3.
Good. No. Log base 3 of 1 is 0.
0.
And what's the log base 3 of 9? 3 to what power equals 9?
Oh, 2.
2. So that worked out. So again, to do this problem, we're going to first get rid of the 6. Now let's rewrite this as an exponential. So e to the 5th equals 2x. So x equals e to the 5th divided by 2. There's your answer. If they want it in a decimal form, punch it in your calculator.
Mm-hmm.
New car depreciates in value at a rate of 8% per year. If you bought it for 2,000, how much will it cost for 5 years? So depreciating. So when we have something like this, you always start with 1, but you subtract that rate, and it's raised to the t, where t is the number of years, and then you put the principal out in front of it, and that's how you come up with the amount. Because whatever your original amount was, every year it's decreasing by that much. So you're multiplying the value by that percentage. Let's say it decreased by, well, it said by 8%. So that means you're multiplying this by 92%. Because if it's lost 8% in its value, then that means it only kept 92% of its value. So that's why you're doing that. You're subtracting that rate. Okay, so if you bought it for this is your principal. This is your time. This is your rate. And just plug and chug and then solve. So A equals the principal times 1 minus 0.08 to the T, which is 5. So you can just punch that into your calculator is all you really need to do. You don't have to do it in your head or anything like that. So 20,000 times 1 minus 0.08 raised to the 5th power. So it's worth $13,181.63. Okay.
Mm-hmm.
How long will it take to be valued at 5,000? We'll plug in 5,000 for A and solve the equation. I can just write 0.92 here, right?
Mm-hmm.
0.92 to the 5th. So divide by 1,000, that's what, 1/4?
Yeah.
It's now worth 1/4 of its value. How long will it be until it has 1/4 of its value? Whoops. I'm putting 5 up here. I should be putting a T up here because I don't know the years in this instance. So take the natural log of both sides or the log of both sides, either one. The log. So that T comes down to the front. So T log of 92 equals the log of 1/4. So T equals the log of 1/4 divided by the log of 92. See what that equals. Holy cow, get out of here. The log of 1/4. Did you do it already?
Yeah, 16.6.
Nice. You're so much quicker than me. I'm so tired right now. Something's not right with the way I did that. What I punch in wrong there?
0.92. You put in.
Oh yeah. It's 0.92. Well, you get it. You did it faster than I did, so you get it. 16.625. About 16 years, it'll be worth that much. Okay.
Mm-hmm.
Good. One last one.
Yeah, I think that's the last one.
Oh, let's do it. No, I don't think we've done this one yet. So this is log of x plus 4 equals log of 4x. So this equals that. Subtract x from both sides. Divide both sides by 3. 4/3 should be it. Let's see if it works. Let's put 4/3 in. Sorry. I said 4/3. It is 4/3. 4/3, let's store that for x. And now let's punch in the equation. Ready? Log of x plus 4. Do I care what this answer is right now? I don't even care. I care that this is the same as this one. So log of x plus the log of 4. Whoa, that's not right. Log of x, close it off, plus the log of 4. And how about that? They're the same. Sound good?
Yep, that's it.
All right, you can watch that like you know on my YouTube channel. So enjoy. Whoops. And I will